Okay, cool. So this question says evaluate the sum to n terms. The first part is 1 upon 1 into 3 plus 2 upon 1 into 3 into 5 plus 3 upon 1 into 3 into 5 into 7. Okay, so what's the deal? You have the first two natural numbers, first two odd natural numbers over there, then you have the first three odd natural numbers, then you have the first four odd natural numbers, and you have 2 minus 1, 3 minus 1, and 4 minus 1 over there. Okay, so we want to evaluate this sum somehow. All right, how can we do that? You can see that, okay, you go by multiplying of 5 over there. That's nice. So what can you do for that? You have 2 minus 1 over there. Then you have 4 minus 1 over there. No, wait, not 4 minus 1. um 3 minus 1. Okay, so that's still very weird. Fine. Let's see if we can break this into two series which we might be able to solve. So this can be written as, you have first of all you have just 2 minus 1. Okay, fine. So you have 2 upon 1 into 3. Then you have 3 minus 1, so 3 upon 1 into 3 into 5. Wait, okay, fine. So that is like we are changing the series. So if we want to know what this series is, first of all we should try to calculate what that thing is. So that's not the nice way out. Okay, so what should we be doing instead? 1 2 and 3. Wait, it's 3 5 and 7. So maybe 7 minus 5 plus 1. Okay, okay, all of them have difference too. Maybe we could use that. So let's try doing it. So let's divide this by 2 and multiply by 2 as well. Yeah, that does give me 6 and 4 and 2 over there. But then how do I use it somehow? We are stuck. uh, so you will have 2. Okay, but 2 can be written as 3 minus 1, and then 6 can be, wait, no, that's 4. Okay, 4 can be written as 5 minus 1. So yeah, wait a second, I know that this thing can actually be written in a different way. So yes, I think I got it. So 1 upon 1 into 3 plus 2 upon 1 into 3 into 5 plus 3 upon 1 into 3 into 5 into 7, and it keeps going like that. That thing can be written as half of 2 upon 1 into 3 plus 4 upon 1 into 3 into 5 plus 6 upon 1 into 3 into 5 into 7, and it keeps going like that. But that thing can be written as half of, well, what's 2? It's just 3 minus 1 upon 1 into 3. Then 4 is just 5 minus 1 into 1 into 3 into 5. Okay, so the thing is that 1 1 minus 1, that pretty much gives me the previous term. But then but then the 5 over there, that also gives me the previous term. So yeah, that's a nice thing. Okay, wait, no, minus 1 gives me the next term, and that 5 on the numerator gives me the previous term, right? That's more like it. Okay, and then 6 can be written as 7 minus 1 upon 1 into 3 into 5 into 7. Keeps going like that. Well, that thing can be written as half of, this thing is nothing but 1 upon 1 minus 1 upon 1 into 3 plus, well, this thing can be written as okay, plus 1 upon 1 into 3 minus 1 upon 1 into 3 into 5. Okay, and then this thing can be written as plus 1 upon 1 into 3 into 5 minus 1 upon 1. Okay, yes, as we expected. So that 7 in the denominator, that gives me the previous terms, the previous term, and that minus 1 gives me the next term. But then the previous term will get cancelled with the next term of the previous. You get the idea that this thing will get cancelled with this thing. So it will proceed like that till what? So it's the sum to n terms. So what happens when you put n in there? You get n upon 1 into 3 into 5 into 7. Right, so like half of that is supposed to be 2n and stuff. So that okay, so the largest number in the denominator, that has to be 2n plus 1. So the previous term that supposed to be 1 upon 1 into 3 into 5 all the way till 2n minus 1, and minus 1 upon 1 into 3 into 5 all the way till, yes, 2n plus 1. That's correct. Yeah, that's a nice thing. This was a nice question, fine. But then this cancels completely, right? I mean, everything completely cancels except the first and the last term. So that's supposed to be half of 1 minus 1 upon 1 into 3 into 5 into 7 all the way till 2n minus 1. Okay, so that cannot be calculated that easily. Yes, you could write it in terms of, okay, let's just write it in terms of factorials. Maybe that will help. So that's just 1 minus what remaining numbers you have. You have 2 into 4 into 8. Well, 2n minus 1 is supposed to be an odd number, so the number which is just before that, that's missing. So 2n minus 2. And then over here you will have the completed factorial, right? So you will have 2n minus 1 factorial. So that's half of 1 minus, well, there are n minus 1 numbers over there, so 2 power n minus 1, and then you will have n minus 1 in the last, so n minus 1 factorial, okay, cool, upon 2n minus 1 factorial. So yeah, that's how you do it. That's a nice question. I mean, that's a really nice question. This is somewhat different from the usual telescoping series we see. That's why I like it. Okay, cool. So the next question is, I mean, the second part of the first question. It is 3 upon 1 squared into 2 squared. Oh yeah, it's just okay, fine. Let's just do it. So TR, that is given by, for the first term you have R plus 2. Okay, fine. So R plus 2 upon R squared into R plus 1 squared. Yeah. So that thing can be written as, let's see, what do we have? We have that 3 is 4 minus 1, which is just 2 square minus 1 square. Similarly 5 is just 9 minus 4, which is 3 square minus 2 square. And you can already see the pattern that R plus 1 squared minus R squared, right? I think we are going correct on that. Is this supposed to be R plus 1 or what? 2R, okay. Yeah, we are going correct on that. So wait, no. This is not R plus 2, it is 2R plus 1, sorry for that. So it's just 2R plus 1. So that thing upon R squared into R plus 1 squared, which is 1 upon R squared minus 1 upon R plus 1 squared. Okay, so if we sum this up from R equals to 1 to n, of this thing, like TR, what we will get is 1 upon 1 squared minus 1 upon 2 squared plus 1 upon 2 squared minus 1 upon 3 squared plus 1 upon 3 squared minus 1 upon 4 squared, all the way till when you put n in there, so 1 upon n squared minus 1 upon n plus 1 squared. Okay, and then some stuff cancels as always, so that's supposed to be equal to 1 minus 1 upon n plus 1 squared. I won't simplify this because that's enough calculation already, so that could be our final answer. Okay, cool. So the next question, I mean the next part of this question is 1 upon x plus 1 plus 2x upon x plus 1 into x plus 2 plus 3x squared. Okay, fine. So that's very different. So here the exponent is increasing in AP as well. Um, it is almost like this thing, isn't it? Yes, it, okay. I mean, over there the value of x was 1 and that's why it was turning out to be something like that. Here x is a variable, so maybe we should try doing it in a similar fashion, that we should write okay, wait, what can we do? So in the previous one we multiplied by 2 And should we multiply by 2 over here as well? Maybe we should multiply by x. Okay, so x plus 2 minus 1. Wait, what? That's not making sense. X plus 1 minus 2. Okay, 5 and 3. Oh, so here there were. Okay, here there was a 1 term over there. No, the number of terms are different on the denominator. That's why it's not working enough. Okay, so these are all consecutive numbers, and that's why it won't work like the above question. Okay, so what can we do in that case? We have to apply a similar kind of approach for this, that maybe x plus, okay, x plus 2, yeah, x plus 2 minus 2, that gives me x, and then x plus 3. Wait, what can we do in this case? 3x squared. This is like a ratio. Okay, it is a ratio. Fine. So what can we do? Um, x upon x plus 1. Okay, so you have 1 upon x plus 1, then you have 2x upon x plus 2. Then you have 1 upon x plus 1, 2x. No, it's not working. Then 3 by 2, that doesn't work. Okay, fine. So um, you want to have a quadratic, right? So x squared plus 3x. Wait, wait. What can we do is that look at this thing, x plus 1. Okay, okay, fine. Not this one maybe. So x plus 1 into x plus 2 is just x squared plus uh, plus 3x plus 2. Okay, fine. So wait, but we want 3x squared, so that's not working. Minus 3x, no, that won't work. Okay, what about x plus 1 into x plus 3? So that's x squared plus plus 4x plus 3. That doesn't work as well. Okay, okay, fine. So we need to find some other way of doing it. So you have 3 and 2 and stuff. Wow, I was never expecting this kind of question. It's almost like, oh yes, it's almost like the answer which we got from this question. I mean, you have something raised to some power, and then you have something factorial on the denominator. Okay, but then how do we find the sum of this question? um you could write 2x as x plus x, so x upon x plus 1 plus x upon x plus 2, but that's not a nice strategy. Okay, what about x plus 2 minus 1? Okay, wait a second, what about their squares? Because no, but then the power is also increasing, so that won't work. You do want to figure out something which has an increasing power. um x squared plus 3x plus 2. All right, so look at that, x squared plus 3x plus 2, and then you have x plus 3 over there. What can we do with that thing? We can write it as x into x plus 3 plus 2, and then this thing is obviously x plus 3 over there, and we just want to have 3x squared. Okay, fine. So maybe not do that yet. Right, so we want to have x squared over there, so in that case we want to eliminate these terms. That's not so easy to eliminate, right? um so the sum, maybe it's like 1 plus 2 is 3. Fine, it's not working. What about x squared plus 6x plus 9? No, that doesn't work as well, so that's not working. The only thing we know is that these terms are actually consecutive, and these are in an AP, so the difference squared, something like that. How do I generate x squared over there? This, I mean, what about we try to think, how do we go from this term to that term? we have to multiply by x plus 2 on the denominator, but then you want a 2x over there. Okay, so is there anything which is common in that? So like 1 upon x plus 1 is common. Okay, then you have 2x plus 2. This is really weird. I was not expecting this. So x squared, what about I do it like this, like x upon 1 plus x? Maybe that can work. Yeah, maybe. I mean, 3 can be written as. Wait. What is the relation between 2 and 1 plus 2? Okay. So that's fine. So like 1 plus. One of the things is that over here you have this 1 and then you have this 1, then you have this 2 and that 2. So that tells me that maybe I should be thinking of, okay, yeah, maybe that can work. Just maybe that can work. I'm not sure about that. So what about okay, fine, so like square that or something. Now 3 upon, wait, let's try it out. I mean, now that we don't know anything about it, we are free to experiment around, right? So let's try multiplying this by something like x to the negative 1 power. Okay, so over here x to the 0 power, so just leave it like that. I mean, not, maybe don't leave it like that. So x to the negative 1 power, and then 1 plus x to the negative 1 power. Then this thing can be written as yeah, that thing can be written in similar fashion. 2x to the negative 1 power upon yes, 1 plus x to the negative 1 power, and then 1 plus 2x to the negative 1 power. But then what I initially thought was very different than this, so maybe that's not the way we should be going. 3 upon x squared, and then there you will have an x. Oh, that's not nice. So yeah, it's kind of working. Let's see what happens. So like plus 3 x to the negative 1, and then you have 1 plus x to the negative 1, and 1 plus 2x to the negative 1, then 1 plus 3x to the negative 1, and it keeps going like that. So how can we generate 3x to the negative 1 from this thing? Well, 3x to the negative 1 is just 1 plus 3x to the, oh yes, maybe we can do it in a very similar fashion as what we did before. Right, this is turning out to be really nice. So let's try to rewrite this. So what can x to the negative 1, and now I'm tired of writing x to the negative 1, so I'll just call this a new thing. Call this a. So you will have a upon 1 plus a plus 2a upon 1 plus a into 1 plus 2a plus 3a upon 1 plus a into 1 plus 2a into 1 plus 3a, and it keeps going like that. Okay, so this a can be written as a plus 1 minus 1. Okay, that's nice. So this can be written as 1 plus a minus 1 upon 1 plus a, then plus this 2a can be written as 1 plus 2a. Right, this is going to telescope after all. So yes, and then 3a can be written as 1 plus 3a minus 1 upon 1 plus a into 1 plus 2a, then 1 plus 3a. Okay, cool. Let's see if this actually telescopes. So you will have 1 minus 1 upon 1 plus a. Then the next term you will have 1 upon 1 plus a minus 1 upon 1 plus a into 1 plus 2a. Then you will have 1 upon 1 plus a into 1. Oh yes, this does telescope. Right, it's almost the same kind of telescoping as what we saw before that. So yes, it did have some connection with the previous question, not a direct one, but yes, its telescoping is almost similar. So now we need to figure out what's the nth term of this sequence. Well, that's supposed to be equal to nx squared. I mean nx to the n minus 1 power. Okay, fine. Upon how many will you have? Okay, you will have n brackets, so that is x plus 1 into x plus 2 uh, all the way till x plus n. Okay, well that thing can be written as n a upon 1 plus a into 1 plus 2a into 1 plus 3a all the way till 1 plus na. Okay, fine. Which then further can be reduced to so that na can be written as 1 plus na minus 1. So we'll have minus 1 upon 1 plus a into 1 plus 2a all the way till 1 plus na, and over here we'll just have 1 upon 1 plus a into 1 plus 2a all the way till 1 plus n minus 1a, right? 1 plus n minus 1a. That's nice. This is like really nice. Okay, cool. So what happens is that all of these will get cancelled and you will be left with this thing 1 minus 1 upon, yeah, this thing 1 plus a and then 1 plus 2a and stuff, and then till 1 plus n into a. So let's rewrite this as, well, a can be written as x to the negative 1. So that's supposed to be x to the, how many brackets do you have? You have n brackets, x to the n, upon x plus 1 into x plus 2, x plus 3, all the way till x plus n, right? This was a nice question. Yes, and we didn't involve multiplying by something. So yeah, that's it. That should be the final answer. So 1 minus, this thing can be written as x to the n times x factorial upon x plus n factorial. Nice. That's a pretty looking answer. Okay, let's go to the next question. The next question is, find the sum to n terms of a1 plus upon 1 plus a1 plus a2 upon 1 plus a1 into 1 plus a2. Okay, so it is almost like these questions, and now that we have had enough practice, I think it shouldn't be too hard to figure out how to solve this. So 1 plus, okay fine, a1 upon 1 plus a1, a2 upon 1 plus a1, right? Just do the similar thing, that write a1 as 1 plus a1 minus 1 upon 1 plus a1. Okay, then a2 can be written as 1 plus a2 minus 1 upon 1 plus a1 into 1 plus a2, and it keeps going like that. So that can be written as, let's just erase this. So that can be written as 1 minus 1 upon 1 plus a1 plus 1 upon 1 plus a1 minus 1 upon 1 plus a1 into 1 plus a2, then plus 1 upon 1 plus a1 into 1 plus a2 into, okay, nothing, okay, into nothing, and minus 1 upon 1 plus a1 into 1 plus a2 all the way till 1 plus a3, and then it will keep going like that till we have n terms, right? So sum to n terms. So where here you have 1, then you have 2, then you have 3, so eventually you will have a n and then n brackets in the denominator. So the last term is going to be minus 1 upon, just as we saw earlier, this is supposed to be 1 plus a1 all the way till 1 plus an, and then the previous term will cancel with the previous, I mean the last term of the previous thing. Okay, you get that, yeah, and then everything will cancel. Okay, so all that I will be left with is 1 and the last term. What's the last term? The last term is minus 1 upon 1 plus a1 into 1 plus a2 all the way till 1 plus an. So that's another kind of telescoping which we learned. So this, I think I should call this consecutive telescoping, I don't know, because you have consecutive terms in the denominator in pairs of 2 or 3 or some fixed number, and then over here you have all the terms which we saw before multiplied in the denominator. So that's a different way. Okay, that's a different way of telescoping. Fine. Let's do the next question. So find the sum to n terms of, let's just first erase this thing. Okay, so find the sum to n terms of x upon 1 minus x squared plus x squared upon 1 minus x to the fourth plus x to the fourth and 1 minus x to the eighth. Okay, so looks like the previous one, right? Oh yes, it is almost like a previous telescoping thing. So x upon 1 minus x squared can be written as 1 minus x into 1 plus x. Wait a second. No, don't write it like that. That will just, or maybe I should write it like that. I don't know. Let's just leave it like 1 minus x squared. Yeah. First of all, let's just take an x common and let's see what we get. So x common, you have 1 upon 1 minus x squared. Then you have, wait, no, that won't work. That just won't work. That wouldn't work. Okay, fine. So our sum is right. So this thing can be written as x upon 1 minus x into 1 plus x plus x squared upon 1 minus x squared into 1 plus x. I know that this won't telescope, but let's see what we get. Maybe we'll get the sum itself in our manipulation, so then we can just find the sum from simple algebra. Okay, then you have 1 minus x to the fourth into 1 plus x to the fourth. Okay, cool. And then this keeps going like that. So this thing can be written as let's first of all multiply this sum by 2. So 2 times sum is supposed to be 2x squared plus 2x squared and this thing over there, right? Yeah, that is okay, but not really what I wanted. So what can we do? Hey, I think I see something nice over there. I once did this kind of thing in the uh, in a in a previous my maths homework video. So what that thing was that I wrote this like this. Okay, so you have 1 minus x into 1 plus x. Okay, then you have x squared upon, you will see what I'm going to do, 1 minus x into 1 plus x into 1 plus x squared plus x to the fourth upon 1 minus x into 1 plus x into 1 plus x squared into 1 plus x to the fourth. And you can already see the pattern that you have x squared over here and over here and x over here and over here, and it is almost like this thing, right? So yeah, that's a nice thing. So now we know how to telescope these sums. I can write x as 1 plus x minus 1, so that will give me 1 upon 1 minus x, but minus 1 will give me minus 1 upon 1 minus x into 1 plus x. Okay, cool. And then this thing can be written as x squared can be written as 1 plus x squared minus 1, so that is plus 1 upon 1 minus x into 1 plus x. Okay, and minus 1 upon 1 minus x into 1 plus x into 1 plus x squared. Okay, then the next thing can similarly be written as plus 1 upon 1 minus x into 1 plus x into 1 plus x squared. Okay, minus 1 upon 1 minus x into 1 plus x into 1 plus x squared into 1 plus x to the fourth, and it will keep going like that, so things will cancel out. Now we just need to figure out what's the last term. So when you will put n in there, um wait, find the sum to n terms of this. Okay, fine. When you put n in there, you get x to the n, no wait, x to the 2 to the n. Okay, so we'll have x to the 2 to the n upon 1 minus extra 2 to the n. So that will be the last term, but negative, and you won't have that over there, you just have 1 over there. Okay, that will be our last term. So till minus 1 upon 1 minus x to the 2 to the n, which is nothing but 1 minus x into 1 plus x into 1 plus x squared all the way till till something till 1 plus x to the n, I think. Yes, so this thing is just going to be 1 minus x to the 2 to the n power. Okay, fine. So that's it. That's okay. This thing completely collapses to 1 upon 1 minus x minus 1 upon 1 minus x to the 2 power n power, and then you can simplify this, but I won't. And that's it. That's how you solve these questions. Okay, and we also have to show that the sum of infinite terms is x upon 1 minus x if mod x is less than 1. Okay, cool. So if mod x is less than 1 and you have that n goes to infinity, in that case this thing x raised to 2 power n, that will go to 0. So you will just have 1 upon 1 minus x minus 1, which turns out to be x upon 1 minus x. Okay, that's nice. So it is exactly what we were supposed to prove. Fine. So hope you enjoyed, and I will see you in the next video.